Section 2.7 is all about inequalities. So problem like number 17, we've got x to the fourth plus 4x plus 4 greater than or equal to 9. We're trying to figure out what makes that statement true. So first thing I would suggest is get everything on the same side. So let's subtract 9 from both sides. We have x squared plus 4x. 4 minus 9 gives us negative 5. And for right now, let's just set it equal to 0. We can really treat it like an equality, but then we'll figure out what to do with the inequalities later. So we're going to factor this out. X squared plus 4x minus 5, we can factor out into x plus 5 times x minus 1. So those two numbers, the negative 1 and the positive 5, multiply to negative 5, but then they're also going to add to b value of 4. So what values make x make this equal to true? We got x equals negative 5, and x equals 1. Now these are not our solutions, but these are critical values for our information here. So what we're going to do is make a number line, and we're going to put those values on here. So here's 0, here's 1, and then 1, 2, 3, 4, 5, negative 5. I'm going to put open circles there, but they are going to be filled in because we're dealing with greater than or equal to. Since it's got the equal to part, we're going to fill those in. Now we got to test this out because our answers could be off to the left here, they could be in the middle here, or they could be off to the right. So let's just start with testing off something on the left side. So test x equals, let's do one on the left side, negative 6. Plugging that back into the original equality, we'll do negative 6 squared plus 4 times negative 6 plus 4. Checking to see if that's greater than or equal to 9. I'm going to put a question mark because we don't know. We're testing it out. Negative 6 squared is positive 36. Plus 4 times negative 6, that ends up being a minus 24. And then plus 4, seeing if that's greater than or equal to 9. 36 minus 24 is 12. Plus 4 is 16. Is 16 greater than or equal to 9? It sure is. So that means we're going to have solutions over here. We should also test in the middle there. We're going to test out x equals 0. So plugging that in, we get 0 squared plus 4 times 0 plus 4, checking to see if that's greater than or equal to 9. The nice thing about plugging in 0 is things cancel out. We got 0, 0. So we end up with 4 greater than or equal to 9. Nope, doesn't work. So we're not going to shade in that 0 area, so we're not shading in the middle. Let's test one off to the right side. So I'm going to test out x equals 2. So we have 2 squared, I'm going to put that in parentheses, plus 4 times 2 plus 4, checking to see if that's greater than or equal to 9. 2 squared is 4. 4 times 2 is 8. So we have 4 plus 8 is 12 plus another 4. We got 16. Is 16 greater than or equal to 9? It sure is. So we're going to put our other arrow over there. Now, since our x's are over here, we're going to say this side is x less than or equal to negative 5. Over here, if you're not so sure how to write it, well, you can say it's to the right or greater than 1. So we're going to say x greater than or equal to. I'm sorry, I forgot the equal to. Greater than or equal to 1. And we're going to say it's either x less than or equal to negative 5 or x greater than or equal to negative 1. Now I'm going to go back a second. I'm going to erase my answer there. If you are not so sure how to write your inequalities, I would just put the x's over wherever it's shaded, or in this case wherever the arrow is, and put your numbers over your dots. So we have a 1 here and we have an x here. And then just put your inequalities, it's going to be a less than or equal to in this case, in between them. You could also say x is less than or equal to negative 5 and 1 is less than or equal to, or 1 is less than or equal to x. That's another way of writing our inequalities.